periodic table is a systematic arrangement of elements based on their atomic number and chemical properties. It helps us understand the relationship between elements and predict their physical and chemical behavior. By studying periodic trend, we can identify patterns in atomic size, ionization energy, electronegativity, and reactivity across the periodic table.
The history of periodic table began with John Euclid, who introduced the law of octave. By arranging elements in increasing atomic mass and noticing that their properties repeated every 8 elements similar to the musical notes. However, this arrangement was not suitable for all elements. Later, Dmitri Mendeleev developed a more systematic periodic table based on atomic mass and chemical properties. He left gaps for undiscovered elements and accurately predicted their properties, which proved that his table was reliable. Finally, Henry Moseley improved the periodic table by arranging elements according to atomic number instead of atomic mass. This correction led to a more accurate organization of elements and formed the basis of the modern periodic table that used today.
The periodic table is arranged in a very systematic way, so elements with similar properties line up together. Number 1, by increasing atomic numbers. Elements are ordered from left to right by atomic number, which is number of protons. For example, hydrogen have 1 number of protons, while helium have 2 number of protons. Number 2, rows or periods. Horizontal rows are called periods. Elements in the same period have the same number of electron shells. As you move across a period, elements change for metals, metalloids, and non-metals. Number 3, columns or group. Vertical columns are called groups. Elements in the same group have the same number of valence electrons, so they have similar chemical properties. For example, group 1, which is alkali metal, are all very reactive. Number 4, block as PDF. The table is divided based on electron orbital. S block for group 1 until 2 at the left side, P block group 30 until 18 at the right side, and D block, which is transition metal, in the middle, for F block in the bottom. 5. Metals, non-metals, and metalloids. Metal left and middle, while non-metal at the right side. Metalloid along the zigzag line.
Today, I will explain the major group in periodic table. Elements in the same group have similarity properties because they have the same number of electrons and valence electrons. First group is group 1. Elements are called alkaline metal. They are very reactive, especially with water, and they are usually stored in oil and prevent reaction. Next one is group 2, which is alkaline earth metal, are less reactive compared to the group 1. Calcium is important for strong bone and teeth in our body. Other than that, group 17 is contain halogens, are highly reactive because they are one more electron become stable. Chlorine is commonly used in disinfecting water. In addition, group 18 is noble gases, are unreactive because their outer shell are full. Helium is used in the balloons, and neon is used in advertising light. And the last one is transition metal, are important in daily life. For example, iron is used in conduction, and copper is used in electric wire. In conclusion, the periodic table helps us understanding the major group, make chemistry easier to learn.
Regarding classifications of elements for periodic table, one of the most fundamental ways to classify elements is by their electron subshell. The periodic table is divided into 4 blocks based on which orbital is being filled by the valence electron. For the first one, S electron,
includes group 1 and group 2. For the group 1 alkali metals and group 2 alkaline and earth metals plus helium, they are highly reactive metals that easily lose their optical substitutions. Second, for the P block, includes group 13 to 18. This block is unique because it contains all states of matter, metals, metalloids, and non-metals. Next, D block, or transition metals, found in group 3 to 12. These elements are metals. All metals are unknown photomic compounds and having multiple oxidation states. And for the last one, F block, in the below, these are what we call inner transition metals. These are the two rows, as we can see at the bottom, lanthanides and excitonides, and many more radioactive or synthetics that we can find in this block.
Electronic configuration show how electrons are arranged in the shell of atoms. It also explains why elements in the same group behave similarly. For the first point, group 1, alkali metal, this group has one valence electron, for example, sodium 2.8.1. The single outer electron make this metal very reactive. Second elaboration, for this point, we can go to second group, group 2, alkaline, earth metal. This group has two valence electrons, for example, magnesium. Having two outer electrons makes them less reactive than group 1. Group 17, halogens. This group has 7 valence electrons, for example, chlorine. They are highly reactive because they need one more electron to complete their outer shell. Group 18, noble gas. This group has full outer shell, for example, neon. This makes them very stable and unreactive. Transition metal group 3 to 12. These elements have variable number of valence electrons. For example, iron. This gives them complex properties and allow them to form colored compounds. In conclusion, electron configuration help us understand the chemical behavior of elements and why elements in the same group share similar properties.
Atomic radius refers to the size of an atom. Across a period from left to right, atomic radius decrease because of the nucleus charge increase, pulling the electron closer to the nucleus. Down a group, atomic radius increase because of the addition of electron shell, which make the atom larger. Ionization energy is the energy to remove an electron from an atom. Across a period, ionization energy increase because the electrons are more strongly attracted to the nucleus. Down a group, ionization energy decrease because of the outer electrons are more easier to remove and further from the nucleus. Electronegativity is the ability of an atom to attract electrons in a chemical bond. It increases across a period as the nuclear charge increase and decrease down a group as the atomic size increase and the shielding effect. Electron affinity refers to the tendency of an atom to gain electron. Across a period, electron affinity generally become more negative, meaning atom easily accept electron. Down a group, electron affinity become less negative because the added electron is further from the nucleus. Reactivity describes how easily an element undergoes chemical reaction. For matter, reactivity increase down a group and decrease across a period. For non-matter, reactivity increase across a period and decrease down a group.
For the importance of periodic table, there are plenty actually, but I'm going to highlight that common known of people. Firstly, the importance of it is predicting chemical reaction. The periodic table allows scientists to predict how elements will behave during a reaction based on their position, a position that I have talked before. Second, periodic table help in material development, especially in certain industry. Engineers and material scientists use the table to design, or we can say create, new substances with specific properties like strength, conductivity, or maybe heat resistance. Thirdly, periodic table mainly used in medicine, engineering, and environmental science. When it comes to medicine, this table used to develop radiopharmaceuticals for cancer treatment or to find elements like lithium, magnesium, to use in mood stabilizer and dietary supplements. And for engineering, for majority nodes, vital for creating superconductors, aerospace materials, and battery technology. I have give the example. And lastly, for the environmental science, we can know it's used to track pollutants like heavy metals and understand their toxicity based on where they sit in the table relative to essential biological elements.
In conclusion, the periodic table helps us organize all elements in a clear and systematic way. It shows patterns in elements' properties and helps us predict how elements behave. By understanding the periodic table, we can better understand chemistry and how it used in our daily life.